Hi guys, I'm Lee at Ninja Holdings. I'm the CTO, and thank you for coming out and please enjoy the drinks and the pizza. Apparently, people love the really crispy tavern style pizza over there. I do too. Just a little bit about Ninja Holdings. We're actually three companies. We're all in the consumer lending space. What that means is people go online, they apply for a loan, let's say up to $3,000. That's sort of the mainline business that we have going on. Two of our other businesses under the holding companies, one of them is trying to be a credit reporting agency, but not like TransUnion or Clarity or Experian, where those are about loan history. Ours is based off of the consumers like bank transactions, their checking account. And we think that that's an important product and thing to do in the fintech space because, um, for example, there's a lot of people out there that are working like in the gig economy. There's other things that they're doing out there where it's not necessarily tracked in their sort of traditional loan history. And so by providing this product to other lenders, there's a way where people can borrow and they might not have like a traditional like credit report or the history that's up to snuff for that kind of stuff. Last thing I want to say is we are hiring a little bit for all three businesses, staff engineers, senior engineers, and we have a summer internship program as well that's going on. But that's enough about the company. Thank you again for showing up, and we're happy to host. Thank you.
Create your contact you for vacancies.
We'll do that. Yeah, I'll put that over there. But Lee at creditninja.com.
Okay, we will include it somewhere. Okay, great. So let's go next. Yeah, we have a big team of organizers. Not everyone is here today. I prefer to always say that Michelle is our main organizer, and we have former people, me, Jonathan, who is here, who volunteered to assist us with photos initially, and now Jonathan joined as a full co-organizer. And also we have Dan and Josh, who's not here today, but they still play a big role in organizing our events and help us get things going. Yeah, if you want to stay in touch, we use two Slack groups. The first one is at Ruby Central Workspace, and another one at Chicago Ruby. So you're welcome to scan and join if that might be useful for you. We make some announcements there, we exchange information and so on. Also, we record all our meetups, so you will be able to rewatch everything you see today. So if you miss something, don't worry. Well, you are covered. You will be able to rewatch the recording and see everything that we covered today. So Chicago Ruby always looks for help, for assistance. And if you know any organizations who are interested to host us, we are always open for that. And like today, we are hosted by Ninja Holdings. Your organization can be next. So if you are interested and you are open to explore it within your organization, we are always glad to explore other Ruby-powered organizations from our city. And yeah, we are glad to talk through such an opportunity. Usually, I mostly cover this part, and yeah, you can contact me if you have any references. So Chicago Ruby is sponsored by GoToInc. GoToInc is a UI UX and engineering talent as a service provider for Ruby-powered organizations. I'm founder of it, so if you anytime need any help in software engineering, you are welcome to reach out. Usually Michelle represents my company. It's a little unusual to talk about my company by myself, but anyway, yeah, if that might be useful, you're always welcome, and we enjoy working with Ruby-powered organizations. And now let's proceed to our first speaker. This is Ellen from Cisco. Ellen is empathetic leader at Cisco, passionate Rubyist, portable human storyteller, ISK enthusiast, swell photographer, rusty drummer, and owner of too many hats given he only has one hat. Yeah, so Alan, can you try to say something once again?
Hello, hello.
Okay,
Can you hear
we
me?
hear you. Yeah, yeah, everything
Great.
looks. Give me a second. Can you screen share?
How's that?
Did he see
When
us?
it makes you guys really small when it does
Unfortunately,
that.
no.
You
Does it
can't see
look?
the screen share? I see it.
We can see it.
Yeah, I think everything looks good. So yeah, you're welcome.
All right. So this is a talk I call Indispensable. It's a talk I'm going to give at RubyConf in a couple of weeks. Um, so there are still a couple of weeks for me to make modifications. If you have feedback, I'd love to hear it. Okay, let's jump in. So I've been writing software for a very long time. I started way back in the 1900s, which would be a long time in and of itself, but I actually took my first computer science course in 1987, 39 years ago. It's been a minute. At that time, or in that time, I've programmed in at least 10 languages, including COBOL, blah, which I did not like at all. Visual Basic, I actually kind of liked it until I tried real object-oriented programming. And JavaScript, which, I actually like CSS, are my favorite languages, Ruby. I've also lived through half a dozen or more industry-wide transitions, including the internet, agile software development, and Ruby on Rails. And now machines are writing code. I got to say, having lived through all those other transitions, not one of them has had the impact on me that AI is having. In the past, I rejoiced at the changes. The internet felt like a world of creative opportunities opening up to me. Extreme programming felt like it was designed by someone who actually wrote code for a living, not some project manager in an ivory tower somewhere. And of course, I adore Ruby and I tolerate Rails. But lately, I've been grieving. Code was something I cultivated with my own hands. I tilled the soil, I pulled the weeds, I tended to its needs. And now my employer has asked that we do 100% agentic coding. So I no longer get to feel the code as it flows through my fingers. I really miss getting my hands dirty. And as if that's not enough, programmers seem to be dispensable these days. Layoffs this year have been rampant, including folks on my own team. According to TrueUp.io, tech companies laid off 275,000 people between July of 2025 and the beginning of June 2026. That's 6% of the 4.4 million software developers in the United States in 1 year. But contrary to the trend, I believe humans are essential to the process of building software. Even though the role of programmer may be transitioning to AI, we humans remain absolutely essential to the creation of software systems. The machine may be able to write code, but it doesn't know what code to write or necessarily even how to structure it until we give it a prompt. And there's actually historical precedent. We're not the first to face this. Machines have arrived before. And when they did, there were humans in the room whose jobs were threatened. These humans, in this room, known as computers, these talented women, many of whom had degrees in mathematics, ran the numbers for engineers at research facilities across the country. The women in this photograph are computers from the Jet Propulsion Laboratory in Pasadena, California, circa 1960. As NASA and its predecessor NACA started to use IBM mainframes in the mid-1950s, these women's jobs were in peril. Many were reassigned. Some retired, but some remained central to the mission. And this is the story of how these three extraordinary women from NACA's West Area Computing Unit made themselves integral to NASA's Project Mercury. If you're familiar with the book or film Hidden Figures, then you might recognize them. They are Dorothy Vaughan, Mary Jackson, and Katherine Johnson. Three human computers who thrived even as NASA pivoted from human to electronic computing. Before I tell you their stories, though, I want to acknowledge that these women in particular were not just facing new machines. They were facing segregation, sexism, and a society that saw the advanced mathematics they performed by hand as clerical, not professional work. The strategies they used to stay ahead of the machines were forged under pressure many of us do not face today. But the strategies do generalize, and we need them today. So I'm borrowing them here with gratitude. All right. Allow me to introduce you to Dorothy Vaughan. Dorothy joined the National Advisory Committee for Aeronautics, or NACA, in 1943. NACA was the predecessor of NASA, the National Aeronautics and Space Administration. At NACA, Dorothy joined the Segregated West Area Computing Unit, a group of talented mathematicians who did all the calculations required for the aeronautics research going on at Langley, by hand, with mechanical calculators and slide rules. In 1949, Dorothy became department supervisor, making her the first black supervisor at NACA of any gender. And when NACA became NASA in 1958, the Segregated West Area Computing Unit was disbanded. Dorothy and her team were reassigned to the new Analysis and Computing Division inside NASA. In the process, Dorothy lost her management position. She never got it back, but she could see what was coming. IBM 704 and 709 vacuum tube-based mainframes were already doing computing in the mid to late 1950s. In this clearly staged photograph, an IBM 704 at Ames Research Center, it shows this IBM 704 in the Bay Area. The giant building in the background is a full-scale wind tunnel that is still in use today. And we know it's staged because typically men operated the machines and women wrote the programs that performed the calculations. Programming was also considered clerical work because it involved typing. Now, the first fully transistorized scientific mainframe, the IBM 7090, arrived at NASA in November of 1959. Now, this is a photo of the two actual IBM 7090 mainframes that calculated flight data and tracked the Mercury flights in real time. This is also staged, but it gets the demographics right. How can we tell? Well, if you zoom in, you'll see that the woman is holding a program in her hands in the form of a stack of punched cards, each one of which represented a single line of code, which looked like this. As you can see, this particular card is part of a Hello World program. That's the arrow in the upper left. And note that the maximum number of characters per line was 80. So now you know why the first line of your Git commit should be shorter than 80 characters. You're welcome. Just in case we ever go back to cards. But let's get back to Dorothy. No one told her to, but in 1961, she checked out this book from a local library and taught herself Fortran. Then she taught her entire team. Now, in the movie version of this story, that all happened in the West Area Computing Unit. But as I mentioned, that group was disbanded in 1958. Dorothy was no longer the manager in 1961. She was just one of the computers in the pool. And yet she taught her entire team. She went on to become an expert Fortran programmer, and she remained a programmer until her retirement in 1971. In 1958, when NACA became NASA, Dorothy lost her management title. The institution had stopped investing in her career, so she invested in herself. Nobody told her to learn Fortran. There was no program to retrain the human computers, so she built one. She taught herself, and then she taught her team. And that's her lesson. When the ground shifts beneath you, retool. As a programmer today, that might look like going deep into understanding how AI works, and how best to leverage it, and how to gain compliance from LLMs. Next, I want to introduce you to Mary Jackson. Mary joined the West Area Computing Unit in 1951 as a human computer working under Dorothy. Mary distinguished herself as a computer, and 2 years later, an engineer named Kazimierz Czarnecki recruited her to work on the supersonic pressure tunnel, a 60,000 horsepower scaled wind tunnel at Langley. This is different than the one at Ames. This is at Langley Research Center in Hampton, Virginia. She accepted the offer and began working in the tunnel, simulating airflow at nearly twice the speed of sound. Though she switched departments, she remained a computer. Czarnecki saw more in Mary, so in 1956, he recommended that she become an engineer. But to do so, Mary needed to take graduate-level classes in mathematics and physics. Working and going to school meant that she needed to attend the classes locally, but the University of Virginia only offered the night classes at the segregated, all-white Hampton High School. So Mary had to petition the city of Hampton for permission to attend. She was granted permission, completed the courses, and in 1958 she became NASA's first Black female engineer. Later that same year, shortly after becoming an engineer, Mary co-authored a paper entitled Effects of Nose Angle and Mach Number on Transition on Cones at Supersonic Speeds. Now, this paper analyzed the boundary effects. That's the very close to the object air pockets near these conical shapes at different nose angles as it transitions into supersonic speed. And in 1961, she co-authored 2 more papers, Effects of Cone Angle, Mach Number, and Nose Blunting on Transition at Supersonic Speeds, and Boundary Layer Transition on a Group of Blunt Nose Shapes at Mach Number 2.2. Now, these papers were essential research for understanding how to minimize friction and manage the heat generated on the nose of spacecraft and jets traveling faster than sound. Her findings were directly applicable to confirming flight hardware designs, helping the United States return astronauts from space successfully, especially the blunt nose. This is the return angle of the craft. They needed to make sure that that was going to survive. Mary spent the next 2 decades researching airflow at supersonic speeds, the physics of how aircraft and spacecraft survive the transition through Mach 1 and beyond. So Mary was hired as a human computer, but 2 years in, Czarnecki offered her a different path, not just a promotion, a transformation. Stop computing, start engineering. The path had a cost, graduate classes at a segregated high school that she had to petition the city to attend, and years of night school after a full day of work. She paid the cost and transformed herself into an engineer in about 2 years. That's her lesson. The job that hired you may not be the job that keeps you. So be willing to transform. Be willing to become someone new. Now, for me, and for others who answer the question, what do you do, with the answer, I'm a programmer, or I write software, that's going to be a difficult transition. But the shift doesn't need to be as large as Mary's. We could try this on for size. I design software systems, or maybe I'm a software architect. Now, finally, let me introduce you to Katherine Johnson. Katherine joined Dorothy's West Area Computing Unit in 1953. Just 2 weeks in, Dorothy assigned her to the Flight Research Division, where her knowledge of analytical geometry was so advanced, they never gave her back to the computing pool. In those days, it wasn't customary for women or computers to attend the editorial reviews where research reports were finalized. But very quickly into her tenure in the guidance and control branch, Katherine began asking how and why questions about her work, rather than just completing tasks. She also began asking to attend the editorial review meetings. By 1958, when NASA stood up the Space Task Group, that's the team that would put Americans into space, she was the only Black woman transferred in. She worked as a research mathematician in the spacecraft controls branch, but she still wasn't invited to the editorial review meetings. Instead, she was told again and again that it was not customary for women to attend. So finally she asked, "Is there a law that says I can't go?" And finally her boss relented. Once she broke this barrier, she became a regular participant in the briefings. Katherine's expert knowledge in analytic geometry made her a valued engineering partner. And by 1960, she became the first woman in her division to receive author credit for a research report. The paper, entitled Determination of Azimuth Angle at Burnout for Placing a Satellite Over a Selected Earth Position, was the paper that told NASA the launch angle and burn times a vehicle would need to reach orbit and come back down at a specific location. This is how NASA knew where to position the Navy in order to retrieve the astronauts in their capsules. Note that Katherine's name was not the only one on this paper. The other is a man named Ted Skopinski. Ted was Katherine's colleague, and he advocated for Katherine to receive credit, saying, "Katherine should finish the report. She's done most of the work anyway." Less than a year later, Katherine computed the flight data for the launch that sent Americans into space, Alan Shepard's Freedom 7. The flight and the recovery went flawlessly. 2 months later, Katherine hand calculated the trajectory and burn time for Gus Grissom's Liberty Bell 7 flight. The flight and splashdown went well, and the Navy located him quickly, but the hatch on the capsule blew too soon, and Grissom's spacesuit began filling up with water. He had to evacuate the capsule before it sank. The capsule was later located and retrieved in 1999. Katherine didn't just hand compute trajectories, she specified them. In all, she wrote 26 research papers before retiring in 1986. The one she co-authored in 1960, the Azimuth paper, laid out the equations for putting a satellite into orbit and bringing it back to a chosen point on Earth. When she hand computed the flight data for Shepard and Grissom's flights, she was using her own math. Her worth came from her skills as a mathematician, not as a computer. And that's her lesson. Move upstream. Specify the domain. Write the ticket. Include the user story and acceptance criteria. Document the edge cases. Then confirm that the agent generated the correct tests before continuing on to implementation. Do the things that AI cannot. Specify what the system should and should not do. Own the definition. Own the requirements. Get ahead of the machine. That brings us to February 1962. John Glenn is about to become the first American to orbit the Earth. The previous flights were all suborbital. For him to survive, the three women's work has to come together. Dorothy became an expert Fortran programmer in the analysis and computing division at Langley, alongside many other former human computers who'd also made the transition. It was her division that operated these twin mainframes, and it turns out the machines that were supposed to replace human computers were programmed by those very same women. Now, Mary's research on supersonic airflow shaped how NASA understood the brutal aerodynamics of leaving and re-entering the atmosphere. Her work on boundary layer behavior and blunt-nosed bodies helped prove out that the Mercury capsule shape would survive the forces it would face, the heat, the pressure, and then transition through the various Mach speeds of sound. Now, without that work, no one would have known the capsule would hold. Katherine wrote the math. The Azimuth paper defined the equations that the IBM was running. And John Glenn did not trust the machines. Before the launch, he asked the engineers to get the girl, Katherine, to run the same numbers by hand on her mechanical calculator. If she says they're good, he said, then I'm ready to go. She ran the numbers, she said they were good, and so he flew. This is the launch of Friendship 7. Note that the Atlas rocket is a bit larger than the Redstone rocket used in the two suborbital flights. The Atlas is the one on the far right. Both, though, were significantly smaller than the Saturn V rocket that eventually sent us to the moon, which is more than twice as tall as the Statue of Liberty. All right, so this is John Glenn in orbit. That device over his right shoulder is a camera. The gauge over his left shoulder shows the cabin pressure and the pressure in his suit. That star-shaped knob is an emergency override for the environmental controls. If he were to detect a drop in the pressure in his suit, he could pull that to release oxygen directly into it. Easy for me to say. Different components in the cockpit were shaped differently so that the astronaut could detect which control it was, even if they couldn't see it. This is the recovery of John Glenn in Friendship 7. That yellow dye was released in order to assist the helicopters in locating the capsule upon splashdown. And now the capsule's not sinking because it's sitting atop a giant airbag that inflated just before splashdown. Here, President John F. Kennedy inspects the Friendship 7 capsule, along with Marine Corps Lieutenant Colonel and astronaut John Glenn, right behind him. 3 women, 3 different responses to the same disruption, 3 strategies. These 3 strategies are not a ladder. They're not levels. They're choices. Dorothy chose to retool. Mary transformed. Katherine specified. Each of those paths fit who and where they were at the time. 3 strategies, 1 mission, 1 man in orbit on our way to the moon. But I'm still grieving. I'm still grieving my relationship with code, and you might be too. I've proudly identified as a programmer for 39 years, and as a manager, I see it in my team. I see the various stages of grief, resistance, anger, bargaining, etc. So I've also been trying to help them navigate this grief, even while experiencing it myself. It's challenging. It's also empathetic and necessary, especially if I'm going to train my team how to retool the way Dorothy did, encourage them to transform themselves the way Charnetsky did, and enable them to write the specifications the way Skopensky did. But in coming to better know these pioneering women, I'm left hopeful. I'm reminded why I'm actually here. I'm here to serve the mission. The code was how I served in the past. It's how we all served. Like the human computers before us, the task of programming is moving to machines, but the mission is still here. So what do? Well, we retool, we transform, we specify, but we can't do it in a vacuum, because while we're working to find our place, our industry is also at a crossroads. Right now, it feels like we're moving in the wrong direction. Many in the industry see AI and think efficiency. That's a failure, in my opinion, a failure of imagination. Think back to the 1960s. NASA didn't bring the mainframes in to cut costs. Those things were $20 million each. They brought them in because their mission had expanded. They were no longer only doing aeronautics research. The space race had dawned. They were in a race to the moon. And they pulled it off with less computing power than the toaster oven in your break room. In fact, today, a single week of computing on your laptop would have taken an IBM 7090 mainframe longer than the age of the universe to compute. And that's just a laptop. Imagine what we can do with all the computing power in all these AI data centers. With that much power at our fingertips, why are we limiting ourselves to reducing the cost of today's mission? Why not be more ambitious? And I don't just mean for the leaders in the room. It's a choice any of us can make sitting at our desk on a Tuesday morning. Why not upgrade Rails? Why not re-enable the linter rules you never had time to resolve? Why not take on that architectural change that would have previously required too much toil to be worthwhile? And that's why we're essential. AI can provide the thrust, but it cannot choose the destination. The machine can write code, but we're the ones with the ambition to shoot for the moon. When we retool, transform, or specify, we aren't just protecting our careers, We're becoming the architects of new, more ambitious missions. We're turning efficiency gains into real human breakthroughs. The code was just the beginning. The mission is what matters. If we set our sights on the stars together, we can remain indispensable. Thanks. I can't hear the room. I hope there's a good response.
There was around 42. I don't know whether you hear or not.
No, I can't. That's okay.
He just wants us to keep clapping. Any questions? Okay, we don't have any questions.
Great.
So let's take 10 or something minute break, and let's return for the second talk by Tony. Alan, thanks for your talk.
You're welcome.
Yeah, I will notify you as soon as I publish the recording, just in case if you need it.
Thank you. I will. I'm going to have to let you. I'm going to have to drop. My team is about to take on the Bosnian team. So
okay. Thanks
enjoy.
a lot for your talk. Yeah.
You're welcome.
Have a good one. Bye
Take
bye.
care.
Alan. Relationship and patterns is looking for as in abstract algebra. After studying his career in the .NET world, he discovered open source and Ruby on Rails and never looked back. He appreciates clean code and fast tests, sound and reliable architecture, and doesn't like when things break. And I think that his topic confirms his values. Yeah, and Tony, you're welcome.
All right, cool. Thanks.
All right.
Cool. So hi, I'm Tony. I'm a software engineer at HashRocket. We're a web agency that specializes in Ruby, Rails, and React. Thanks everyone for coming out tonight, braving all the hot weather. Thanks ChicagoRuby for having me. There have been a lot of really great pro level conference talks these past few months here, and this will not be one of those. Hopefully it'll still be good. I'm going to be talking about read-only models in Rails today and a utility that I came up with to make testing them easier. Maybe you have read-only models in your app. Maybe you've never heard of them or think they might be useful. And maybe this utility be useful for you. But regardless of that, I think it's worth thinking about while we're going through this is that Ruby is a really malleable and powerful programming language. You can do some really cool things with it, and it allows you to write some really ergonomic tools. So a good way of doing that is starting with thinking through how you want to interact with something and then building that. It's not the most earth-shattering concept, but it never hurts to have a reminder. It's always useful. So let's get started and talk about what a read-only model actually is. I feel like they're not super well known. I only found out about them like in the past year. I've been doing Rails for 8 years. But it's something you can do at the application record level. And basically to make a model read-only, you just override the read-only method and set it to true. It's default by false. Defaults to false. Yeah, so if you set a model to read-only, what happens? If you try to create a model that's read-only, you're going to get an active record read-only exception. And it prevents you from saving the record, which is good. Same with update. Try and update something that's read-only, get that same exception. Same with destroy, kind of get the gist of it. does what it says it does. So why would you want read-only models? They're great if you have certain data in your database or whole database that you don't want your Rails app to change. Maybe you're connecting to some like external database that's read-only, or you have some third-party service that's pumping data into your application's database. Could be connecting to some like legacy app database to get some data out of there. Lots of different options, but and also the underlying table doesn't necessarily have to also be read-only. Like you can have read-only at the database level, and then enforce read-only at the application level too, so you get the same behavior at the application database level, or you can just enforce the read-only at the application level, and database can do whatever it wants. So it's a great way to enforce read-only if you have a read-only database. These kind of active record exceptions are a lot friendlier than but an error you're going to get from the database, a lot easier to parse and deal with. There's probably other reasons why you might want to use a read-only database or read-only models. And a lot of times when you reach for this, it may not be in the most ideal of circumstances. But adding this read-only constraint can be a helpful way to bring some order to some of the chaos that you're dealing with. So on the application side of things, this is great. Keeps data read-only, enforces some constraints that you want. On the testing side of things, this can get a little bit tricky. You might be able to see where this is going. So if you're writing tests that don't touch the database, you're golden, no problems. If you're just using factory bot and building data or initializing and not saving it, stubbing the database, you're good. But what if you want to write a test like this? Say you have like a complicated logic and a scope. You want to be able to test that. And to do that, ideally, you need to put some data into the database. Guess what's going to happen to this test if this read-only thing is read-only? You're going to get that same exception, active record, read-only record. So that's a problem. We can't get data into the database for testing. So before we go and start finding a solution for this, let's think about how we actually would want it to work. So perfect world, we're able to override this and temporarily make the model writable so we can get data in. But also, ideally, we don't want this read-only model to be writable when we're performing the test, when we're executing the test. Because you want your tests to test the application as realistically as possible. And if you're changing a core feature like how read-only it is, you're going to let bugs through. You're going to run into some problems. So ideally, we want to allow writes to these models in test setup, but not during execution. So let's operate under that constraint. So let's start with some simpler approaches and kind of the first things you think of and see where that takes us. You could conditionally gate read-only based on the environment or the environment variable. I generally don't condone doing this, but it also would not work with our constraint because this would be at the environment level. So throughout the whole test, it would be writable. So no go there. Another option we could do is do direct inserts into the table. Bypass active record. I guess you're still using active record to do the insert, but you're bypassing all the active model. And this is what the LLM is going to do. It works. In some ways, it's the most pragmatic approach. It does the thing. But I have a couple issues with it. One, I think it's ugly. And two, it can create a ton of churn if the underlying table changes anyway. You add a new column, you have to update all these inserts. You're also going to get less helpful error messages if you try to insert some data and it's not right. Instead of the nice active model like errors API, you're going to get a Postgres or a MySQL error. And that's not going to be as fun to parse and read and figure out what's going on. So yeah, you could extract this out to a helper. Still doing the direct insert, but you're kind of squirreling that away into a helper method, which cleans up the tests, and then you've got one spot where you can have the actual insert. And that works, but that feels like we're getting a lot closer to FactoryBot. Essentially doing the same thing that FactoryBot does. FactoryBot's got all these niceties. It helps to create fake data and all that stuff. So we could try and flip back to FactoryBot, but that's not going to work because read only. And there's no way to override that with FactoryBot. So it kind of takes us back to where we started. But so now we kind of keep thinking and then see what if we had a way to wrap certain operations and say anything inside this block or whatever is writable. So what if we had something like this where we have this with writable block and anything in that block allows you to write. And in this way, it's a very targeted area that you allow these writes. And then inside of that, you can leverage FactoryBot or helpers or anything, any bit of like Rails or Ruby helpers to help generate that data more easily. It satisfies our need to restrict the writes to just during test setup. And then when we get to the execution stage, the model's back to read only, and we're testing the application as it's going to behave in production. So I think that's a pretty nice API that works pretty well. But then how do we actually make this thing work? And the answer to that is everyone's favorite, metaprogramming. But just a little bit. So this is a method you can throw in. If you're using RSpec, you can throw into our spec support. Ideally, it goes somewhere that's available in tests, but not in app code. I'm sure there's some place in there for like that for mini test. Yeah, this is, I don't know how many lines of code that is. It's about 10, maybe a little bit more. It can look a little bit opaque, but let's kind of walk through it. So we have a method with writable. It takes in a class. This is the class that we want to override and make writable. And specifying the classes makes it even more focused so that it's only going to be on the specific models that we want to override and make writable. So we pass in that class, the read-only thing, and then we use class eval, which allows us to open up the class for modification. We can change the behavior of the class at runtime, which is really powerful. Can definitely get you into some trouble if you go over the top with it, but This is a small enough change. So we'll keep record of what the original value of read-only was, so we can flip it back at the end, and then we can use define method to flip read-only to false, which makes it writable. So at this point, the class is writable. And then we yield anything that we put in that block that now runs, and the class is writable, so we're getting data into the database. So we do that, and then we hit this ensure block, which runs every time at the end of this method, and we pop into class eval, we reopen the class, change read-only back to the original value, and then clean up that original. Yeah.
So obviously this code works. When I look at this code, I would assume that when I get to read only, it would raise a no method error because it's referencing a method that no longer exists. How does that not happen? Obviously, I don't know enough about Rails meta or Ruby metaprogramming.
Which part? This one?
Like, so alias method read only points to original read only. So what I would imagine happens is when I call read only, it says, oh, return me back original read only. And then I remove method original read only. So what I would have imagined, obviously that's not how it works, is that when I call read only after I remove the method, it would return a no method, raise a no method error. But obviously my mental model is wrong because it's working, otherwise you wouldn't have presented it.
Yeah, that's a good question, or a good point. It definitely works. I'm not totally sure. I guess, I don't know, maybe it's copying when it's doing the aliasing, it's actually copying it, or when you're dropping it, it knows that it's aliased to something else, keeps a copy. Something I should check into because now I actually don't know how that works. I'm curious. But yeah, so hit the ensure, we flip it back to read only, and then we're back to read only, test executes, and we're all good. So an easy extension here is what if you had multiple models that were read only and you needed to override that for multiple of them? It's pretty easy to just extend this to accept multiple classes or one. Basically, what array.wrap does, I think it's a Rails method, but pretty useful. If you pass a single item in there, it'll wrap it in an array. If you pass it in an array, it'll just do nothing and you get the array out. So whether you pass a single or an array in there, you're going to get an array out. And then you can just iterate over each class that you want to override, and do the same class eval for each one, open it up, change the read-only value, close it, yield, revert it back, and then do that for every class that you pass in. So yeah, that brings us back to this test. You've got that with writable, use that in test setup, run the write some data, and then test execution runs, and we're all good. So I don't know, I think that's a pretty clean intention revealing way that's friendly to use. And it gets us to a green spec, which is great. So yeah, I guess that's kind of it. Whether you use this or not, I don't know, I think it's worth giving like developer experience or tooling like this a thought as you're building things out. Especially in the age of LLMs, like it's really easy to ignore stuff like this and just kind of use whatever LLM's gonna throw out there. But I still think there's value in kind of optimizing these things for readability and usability. Yeah, it's my talk.
Yeah, question.
Yes.
How did you come across read-only? How did you face it overall? I mean, you said that you bumped into it only a year ago. How did you came across it?
We were working on a project. I think I learned about it from another developer. They had we were accessing a legacy database table that we needed to read from, but like we absolutely did not want to write anything to it. And they found the read-only method and they made it read-only. And we kind of bumped into this and weren't sure how to test it. So it was mostly, we had a few complicated scopes that we needed to test and kind of found this. Yeah.
More questions, yeah. One more question. How do you think, is it like the expected like documented way? Or is it like, was it intended that you can use it like that? Or is it like undocumented feature that is like a hack that works, but actually they probably didn't expect you to use it like that? What's your feeling about it?
So it's I don't think it's documented, but maybe it is in like the active record docs. It's not super publicized or whatever. You kind of have to come across it. So I don't know if that means it's not really
No,
supposed to be used, but it's a public method, so I think it's fair game. There's other stuff in active record where you can set specific columns to read only, and that's a different method or a different way of doing that. I think that's a bit more documented. Yeah.
I'm not sure, maybe it was on your slides. If you will try to call create with an exclamation point or update with an exclamation point, will you still receive this exception?
Yeah, with or without the bang on creator update, you'll get the exception. Because it'll
So this like bang exclamation, it will bypass validation, but it wouldn't bypass read only, yeah?
does bang
I mean,
go past?
I think if you call create with an exclamation point, it bypasses all the validations as far as I remember. And I was curious whether it bypasses read only or not.
I thought the bangs would like, is that only on save? A bang would like raise the exception versus return
Yeah, maybe,
false.
maybe just
So there's update column and update attributes, which bypasses validations. That goes straight to the database.
I mixed them up.
I think you could probably, I think those updates will work. I'm not sure. I haven't tested that.
And the last question, did you think about any approaches? Maybe you can make initialization, yeah? Can you make new or you didn't test it?
You can new, because new will just
Yeah, I thought
instantiate it
so
in memory.
that we are in Rails world, usually like there is a way how to adjust it. So I thought maybe you can make new, then maybe you can like change property read only to false or whatever. I don't know, I just assume here. So maybe you can work with this specific instance and save it even without metaprogramming.
You could, I haven't tried that. You could probably do that.
No, it's just an idea. It's just discussion. I'm not saying that I'm sure that none of us have all the answers. I'm just thinking about different ways how we can play around it, and it popped out in my head.
Yeah, it's probably doable. Again, that's the nice thing about Ruby is it's so malleable. There's lots of ways to do it, and it's really easy to change things on the fly. That would probably work.
if you say do factorybot.build, you now have an active record model.
Mhm.
If you define a singleton method on that model, like def model.valid return or .read only return false, will you be able to save it, or will active record still fuss at you? Where it's like you're just making that one instance no longer read only.
That would probably work. Yeah, because well, it depends. Like if your read only is only at the application level, then yeah, that would work. If the underlying table you only have read access to it, then it would work at the application level, but the database would raise an exception. But that would probably work too for
How do you even populate the database if the table, you have to like turn off triggers if the database make it read only?
it's a little bit harder if
Yeah.
the database is read only. But also, I guess if you're in test, you can configure your test database differently to be writable. Downside is that also is different from production. You could, yeah, you could probably change the write access to the database when you like spin it up, populate it, and then you're running tests, give it only read-only access.
Did you look into any like mobile solutions before you thought of the platform? Like maybe something that monkey patches into our spec itself?
Yeah, honestly, that's kind of the ideal situation.
I was thinking like overriding or extending it. Would that kind of just automatically apply every time?
Yeah, like
Like the default context and stuff. Where all that creation calls goes.
yeah, I thought of too like on like a describer context block, you can like in Rails you have like the type model, or you can do customizations there. I wasn't able to find anything in RSpec to kind of separate between test setup and test execution. Overriding before or something that could maybe work. 'Cause yeah, there's stuff you can hook into it in RSpec. I just couldn't find a way to do it only at setup. And I really,
It's always been really complicated.
yeah,
Maybe a good AI.
yeah. RSpec's one of those fun things that,
Yeah.
yeah, there's a bunch of metaprogramming in there, I think. But yep.
Thank you.
We're good.
Fine.
Cool.
Guys, I need 2 more minutes of your attention, please. And do you have everything? Yeah. Great. So I want to remind you that you can follow our meetups. No, you can't follow our meetups yet, but soon you will be able to. Technology. So yeah, you can stay updated on all our events on our meetup group. So if you want to know about our next events, that's the right place to go. I'm just waiting so everyone can scan. Okay. So we are really motivated to hear what topics interests you, and maybe like you have some things that you are not ready to explore, but you are very eager to hear about. So there is a QR code where you can enter and suggest topics you are interested to listen about. And also if you want to give a talk, and just in case every one of us has our first talk some time ago. Actually, that's my first time coordinating Chicago Ruby. So, and you even see like English is not even my first language. So you definitely can make a decent talk if you just want to do one anytime. So we have this opportunity. So welcome to request talks you're interested about, and welcome to come talk about things that interest you. Also, Chicago Ruby looks for additional sponsors and organizers who are interested in different kind of events. Like maybe you want to organize a hack night. Maybe your organization want to become a sponsor to help us organize events, like maybe bring some speakers and so on. So yeah, we are definitely interested about it, and reach out if there is any kind of collaboration you are thinking of. We know about several open positions. So firstly, Ninja Holding, our host, is hiring, and I will do my best to publish some information about that. Secondly, we know that Prevail AI is hiring, and we know that Chime is hiring. So yeah, you can scan those QR codes and you will be able to see their vacancies. So we have, as usual, we try to do monthly meetups, and so far in this year we are going quite good with making those monthly meetups. So next month we meet on August 12th. We meet at workforce.com, and yeah, you can see speakers. It will be Kevin Murphy and Zelko Daki, and both talks will be AI related. So yeah, join us remotely or in person if you're interested. Yeah, don't forget that if because of whatever reasons you can't travel, there is an opportunity to join online. That's why we try to dedicate some attention to Zoom, and there are some tech delays related to that. Yeah, that's it. Thanks a lot for being with us today. Thanks a lot for making through this heat to the meetup, and it was great to see all of you today.